going to kick off a group of us that are going to be talking about fecal coliform bacteria and the partnered efforts that we're taking to both monitor fecal coliform bacteria in the Nooksack watershed as well as the county overall, and steps that we're taking to work with landowners to try to identify sources of bacteria and bring fixes to those. So again, I'm Erika Douglas, Whatcom County Public Works. I grew up here in Whatcom County, and yes, I'm a city girl, but I've spent time out in the county, and I continue to stay here and raise my child here because I think it's a great community. It's a great mix of urban and rural, and we all really need to be able to work together to preserve the natural resources that we have here and that keep us all here. So what is it that we're all aiming for here? We're talking about a lot of different parameters, a lot of different things that impact our water quality. But really what brings us all together is we're interested in clean water. We may be coming here for different perspectives and different reasons that we want clean water, but ultimately it comes to clean water for our shellfish, our fish, drinking water, our agricultural practices, for just our kids playing in the streams and in the marine waters. So fecal coliform bacteria, that's the big one that folks are hearing about right now. And that's in the Nooksack watershed, it's in the Drayton Harbor watershed, it's the Birch Bay watershed. These are all areas that are being impacted by increasing bacteria levels. And that affects our ability to recreate in some of these areas. It affects our ability to harvest shellfish in the marine waters. And that's important for both commercial and recreational and tribal shellfish harvesters. So what is fecal coliform bacteria? It's a really small little bacteria that you're not going to see with your blind eye. So you look out in a creek, it looks clear, looks good. I look in another creek and it's really brown and turbid. Does that mean that we've got more bacteria in that brown and turbid creek than in that clear creek? No, not necessarily. So we have to work with the labs to identify how much bacteria do we have here. So fecal coliform bacteria is of concern because it's associated with human and animal waste. And so it's an indicator that we may have human or animal waste in our water bodies. And what is that concern? Well, human or animal waste, fecal materials carry other bacteria and pathogens that can make us sick. And so we want to make sure that we're not putting ourselves in a place where we are going to become sick by going out and recreating or eating our shellfish. And so that exposure can occur just through having kids wading out in the creek, playing around in the water, sticking their hand in their mouth. They can get sick from that. We can get sick from eating shellfish that have bacteria and viruses that are being filtered through their tissues, and then we go and eat them and we get sick. So that's what we're trying to avoid here in this community. So we're talking about bacteria. Where are all the places that it comes from? We should just be able to find the silver bullet, go out and fix this, right? We all know that it comes from one big source, and we think, well, we should be able to just go and take care of that. Well, the fact is that, yeah, there are a few point sources here in the county. We've got wastewater treatment plants. We've worked with a lot of these. So what we're working with now are what we call non-point sources. And that means that we've got a lot of really small sources that when you put them all together, they cause a problem for our community. So it could be anything from leaks in our sewer systems, in our municipal sewer systems, failing septic systems, so people having their own individual sewer system on their land, and that might not be working. Maybe poor manure applications, and maybe dog waste. Could be urban wildlife, it could be that waterfowl, it could be those deer that we see out there. So there's a lot of different sources. So there isn't a silver bullet. It takes all of us working together to identify what are the sources and what can we do to fix them. So a big piece of that is that you've got to have a robust monitoring program to help you identify where your problems are. And so for Whatcom County Public Works, currently we're doing the routine monitoring component. And we have 90 stations throughout the county, and in the Nooksack watershed we have about 18 stations. This work started with the Northwest Indian College, and it was in a partnered effort with the Department of Ecology, the EPA, and a variety of other local state agencies. So we have data that goes all the way back to 1998 that looks at bacteria levels in all of these different streams. And so we have these right now we're down to 18 fixed stations. And what are those stations? Well, we're looking at the main stem of the river. So we want to see what's happening down at the base of the river when we're going into the Nooksack Delta and it's dumping out into Bellingham Bay. And then we also want to see some of these upstream sites. So we look at water quality at Ferndale, we look at water quality at Linden, and we look at water quality as it's coming into Everson. So that's giving us that spectrum of what's happening on the main stem of the Nooksack. We also want to look at all of these tributaries that are coming into the Nooksack. And so we might have Bertrand, Fish Trap, 10 Mile, Anderson. We've got all sorts of different tributaries that are coming in. And so we try and collect samples as close to the point where they discharge into the Nooksack as possible. And we're monitoring this over years and years to get a sense of what's happening from year to year. We sample on a bi-monthly basis, so twice a month we're out there collecting samples at these sites. And these are randomly selected dates. So we're not sampling just when we know it's going to rain. We aren't sampling just when we know it's dry. We're trying to hit all of those environmental conditions. And we look at a 30 sample running geometric mean and a 30 sample 90th percentile, so that we're looking at a period of numerous seasons. We're looking at a variety of environmental conditions. So there are two sets of standards that we're looking at here. We've got freshwater standards and we've got marine standards. And fecal coliform bacteria is a little bit complicated because it's got two sets of criteria within each of those. So for the freshwater system, we're looking at the geometric mean. And so we want to be less than 100 fecal coliform colonies per 100 milliliters. And we don't want more than 10% of our samples to exceed 200 fecal coliform colonies per 100 milliliters. When we get to the marine waters, those standards are a little bit lower. So this is where you're having your oysters and your clams that are living, that we're trying to eat, and they're filtering this water. And so we want to make sure that there is less bacteria in those sites. You're also going to have a lot of dilution and die-off at those points, so you are going to see lower numbers in the marine waters. So there we're aiming for a geometric mean of 14 fecal coliform colonies per 100 milliliters, and an estimated 90th percentile of less than 43. So a little bit complicated, a couple things to be looking at. It's not just a straight shot. But what we can do is look at what are those patterns over time. And so this is really just looking at our last few years, because the concern raised when we started seeing increasing bacteria levels in the Nooksack River again. So back in the late 1990s and early 2000s, we had high bacteria counts in the Nooksack River and in the marine waters. And that caused a shellfish closure. We did a lot of work as a community, and we were able to get those numbers to drop back down. But unfortunately, we're seeing those numbers on the rise again. And so up here on this top graph, we're looking at our main stem stations. So you remember I said we had stations up at Everson and Linden. Those are these stations. So there's a little bit of an increase there, but they're holding pretty steady. And they're definitely lower than what we see as we move down the Nooksack. And so M1, this green line, is at Marine Drive. So that's our lowest portion before it goes into the Delta. And then this light blue line is at Ferndale. So we're seeing that we're having inputs of bacteria as we move down in the system. So we've moved through some urban areas, we've moved through some rural areas. So we have all of these different bacteria sources that may be contributing. And then when you look at the tributaries, this is Fish Trap Creek, we're seeing kind of a similar pattern with increasing levels occurring over those last few years. So you're seeing that coordination between tributaries. Now, not all of the tributaries are showing the same exact pattern, but we are seeing a lot of similar patterns in a lot of these tributaries. What does that mean for the marine waters? Well, like I said, early in the late 1990s, early 2000s, we had these really high counts. We worked as a community. We got those counts to drop way down. But look, as we're seeing increasing levels in the Nooksack, we're again seeing increasing levels in the marine waters. And what has this led to? It's led to almost 500 acres being downgraded from shellfish harvest for the Lummi Nation. This is a big impact to that part of the community. And so they have closure periods now from April through June and October through December because we have too high of bacteria levels to safely be able to harvest and eat those shellfish. So back to this little neck of the woods. Why Bertrand? We have efforts. We can't do everything all at once. We just don't have enough people. We don't have enough resources to reach out to everybody. So we have to pick focus areas. Where are we going to follow our data and go work with landowners to try to fix some of these problems? So Bertrand is one of our focus areas. And the reason that it's a focus area is, oops, let's push that button. So we've got, this is the freshwater standard, this yellow line. And these are the concentrations of bacteria in Bertrand. So this is back in 2000. And again, this is a 30 sample running geometric mean. So you've got about 2 to 3 years worth of data in all of this. So right now, we were seeing that increasing trend. We've had a little bit of a drop here. Could be because of landowner efforts. It could be because of the dry conditions. There are a lot of different factors that may be leading to that drop, and hopefully it's a long-term drop, but we still need to go a bit lower because we're not meeting that water quality standard yet. So right now, our concentrations are above the water quality standard, and then the other piece to look at is right here. So this is looking at a water balance. This is back from the late 1990s when a total maximum daily load study was done, which looks at water quality and how much water you've got coming in from each of these creeks and trying to find where you need to make pollution reductions. But what we found is that when you look at the lower part of the Nooksack, the Bertrand Creek is one of the largest contributors of fresh water into the lower part of the Nooksack. So if you're looking at bacterial load, how much bacteria is being loaded into the system, you want to look at the concentration times the flow. So we've got concentrations that are above our water quality standard, and then we've got the greatest flow coming into the lower part of the Nooksack right here. So that's why we're focusing on the Bertrand. So what is a PIC program? A PIC program is a program that looks at pollution. So we're looking at fecal coliform bacteria. So we're looking at all of those different non-point sources that I was talking about. We're going to identify where our biggest problems are. So we're using this water quality monitoring to identify where are our hottest spots, where are we seeing the greatest bacteria levels where we want to focus our resources. And then we're going to come in and work with landowners and try to identify fixes and get those in place and see if we can improve water quality. And from that point forward, this is some information just about the data aspects where you can find our water quality data that we're collecting every 2 weeks. The Whatcom Conservation District has a great map showing where we're currently at in terms of bacteria levels in comparison to the standards. And then the Whatcom Clean Water Program is all of these partners that you're going to be hearing from here now that are going to be sharing how we're using this data to move forward and working with landowners to get to fixes. Thank you.